All right, today we are looking at angle pairs. Add your name and the date. It is 8/22/19. So, some vocab words that we may or may not be familiar with about angles. We have complementary angles, which would be two angles that add up to 90 degrees. So I'm going to circle that definition. And we have supplementary angles, which add up to 180 degrees. So I'll circle that definition, supplementary and complementary. Now it says in the next part that these could be adjacent or not. Adjacent angles are two angles that have a common vertex and a common side, but there's no common interior points. So it's meaning that they're right next to each other, but there's nothing splitting them up even more. And the pictures below, I think, really help show that. So these two angles right here are adjacent. They're right next to each other. Nothing is dividing them. And they also happen to be complementary because we can see they add to the 90 degree. These ones are not adjacent, but they're telling us they do happen to add to 90 degrees. We have some adjacent supplementary angles because they add to a straight line, a straight angle, and these two are non-adjacent, but it does say that they would add to 180 degrees, and we would never have known that unless they told us the measures and that they did do that. So a few more vocab words we have that two adjacent angles are a linear pair if their non-common sides are opposite rays. So that's a length, I don't know, it seems like a complicated definition. To me, a linear pair are two angles that make a straight angle, or they make a line. They're a linear pair. So I'm going to write above that, two angles that make a line. So this would be a special case of adjacent angles. So this would be this picture. Angles 1 and 2 here are a linear pair. They form a straight angle, a straight line. Another one, they would be supplementary then, since they made a straight line. Our other vocab word is vertical angles. Vertical angles are if their sides form two opposite pairs of rays. So an example of vertical angles would be angle 4 and 5. Are vertical angles, I'll say VA, or angles 3 and 6 are vertical angles. So our math definition is that their sides form opposite rays with each other. The way I think about it in my own words is they are right across from each other from an intersection. So we've got this intersection of these two lines in the middle. 4 and 5 are directly across from that intersection, and we can tell they're the same size. 3 and 6 are directly across from each other in the intersection, and we can tell they are equivalent angles, congruent angles, excuse me. So I'm going to say that they are across the intersection from each other. Across the intersection. Oh goodness. Okay. So lots of new vocab words for today. Let's practice using some of them. In the figure, name a pair of complementary angles, a pair of supplementary angles, and a pair of adjacent angles. So complementary first. I need two angles that add to 90 degrees. Well, 52 and 38 are the numbers that they give me that would add to 90 degrees. So for 52 degree angle, I'm going to say angle ABD, please use 3 letters, and angle BDC, and those are the complementary. They add up to 90. For supplementary, adding up to 180, my two numbers would be 52 and 128. So 52 angle ABD and 128 angle BDE are supplementary. They add up to 180. For adjacent, two angles that are right next to each other, these would be the 38-degree angle and the 128-degree angle. So angle CDB and angle BDE, and those are adjacent. They would not make a linear pair even though they are adjacent, because those two do not add up to 180, so they do not make a line. Okay, so next example, given that angle 1 is a complement of angle 2, so they are complementary, and angle 2, the measure of angle 2 is 57 degrees, find the measure of angle 1. So to show our work, even though you might be able to do this all in your brain in one time, we should write that the measure of angle 1 plus the measure of angle 2 is 90 degrees because they're complementary. So the measure of angle 1 plus 57 is 90 degrees, which means the measure of angle 1 is 33 degrees. That's how we could show our work. For B, angle 3 is a supplement of angle 4, and the measure of angle 4 is 41 degrees. Find the measure of angle 3. So our equation for this one would be the measure of angle 3 plus the measure of angle 4 equals 180 degrees. The measure of angle 3 plus 41 equals 180 degrees. So the measure of angle 3 equals 139 degrees. Part C, an angle has a measure of 50 degrees. What is the sum of the measures of the complement and the supplement? So I need to find both parts and find their sum. So 90 degrees minus 50 degrees would give 40 degrees for the complement, and 180 degrees minus 50 degrees gives 130 degrees for the supplement. And for their sum, 130 plus 40 gives 170 degrees. Now we've got a basketball pole that is tilted. I don't know if basketball poles are normally tilted or not, but this one says this forms a pair of supplementary angles with the ground. Find the measure of BCA, which would be this angle, and DCA, which is this angle. I'm going to give it two arcs because I don't know if those are congruent or not, so I don't want to label them in the same way. So they are supplementary, so I can add them together and I know it would equal 180. So 3x plus 8 plus 4x minus 3 equals 180. So 7x plus 5 equals 180. So 7x equals 175. That means x is 25. Now I have to actually find their measures. So 3 times 25 plus 8 is 75 plus 8, which is 83 degrees. And 4 times 25 minus 3 is 100 minus 3 is 97 degrees for the two angles. Next one, it says identify all of the linear pairs and all of the vertical angles in the figure at the right. So let's do linear pairs first. What are two angles that make a straight line, make a straight angle together? This is important, it is only two. So I can see that angles 1, 4, and 5 together, all three would make a straight angle, but we only want pairs. So the pairs that make a straight angle would be angle 1 and angle 2. They form a line together, as well as angle 2 and angle 3 form a line together. I do not see any other pairs that form a line together, and they have to be adjacent. So 1 and 2 are adjacent, 2 and 3 are adjacent. Then for vertical angles, I'll put them down here. Vertical angles are directly across from each other. Their sides make opposite rays. So again, only can be two angles. So 2 and 4 and 5, if 4 and 5 were together, they would make opposite rays, but we cannot include them. only pairs. So angle 1 and angle 3, their sides are opposite rays from each other. Their sides are two lines that intersect. So angle 1 and angle 3 would be the only pair of vertical angles in this picture. They're right across from each other.